Hello students, welcome back to Physics with Safdar. Now you are watching IGCSE Physics Past Paper Solution series. In this series we solve questions from paper 2, 4 and 6. If you are facing any problem in IGCSE Physics, so you are at the right place. You can find the solutions of your problem. I suggest you follow the playlist of the channel. In that you can find all the things you need for your IGCSE Physics. Today we are going to solve question number 5 from Specimen 2020 series. So let's begin the solution of the day. 5 is figure 5.1 shows a gas contains a cylinder enclosed by a piston. Look at this diagram. This is the gas cylinder. Inside you have a gas. This is piston and this side is equals to 100 centimeter. There is a gauge for measurement of pressure. At the first, the length of cylinder is 100 centimeter. The pressure of the gas shown by the gauge is 300 kilopascal. The area of the cross section of the cylinder is 0.1 square meter. Part A1. Describe the motion of molecules of the gas. You know well about the gas molecules. Gas particles are free in motion and when they move inside the container like that. For example, these are gas particles. Gas particles are random in motion like this. And they move and hit the walls of container. So here you can write the movement of gas particles. Molecules move random in direction and molecules collide with the walls of cylinder. For that you will be awarded 1 mark. Number 2. Use the idea of momentum to explain how the molecule exert a force on the walls of cylinder. Once again jump on the diagram. First of all recall what was the momentum. Product of mass and velocity. For example, look at this particle. It has some mass and it's moving with some velocity. During the motion it hits the wall and exerts some force. After hitting, the object returns. That is change of momentum. So for that of change of momentum you need a force. So what you need to write here, look at this. During random motion, gas molecules collide with the walls of cylinder. That's true. And rebound. Rebound means that hit the container and return. When they return, mass remains same but direction of velocity change. That causes the change of momentum. And that momentum change is equals to force. So finally the force needed to that change of momentum, and you will be awarded 2 marks for this answer. Part B. The piston is moved so that the new length of cylinder occupied with the gas is 40 centimeter. The temperature of the gas is unchanged. Calculate the new pressure of the gas. You know well when the temperature of the gas remains same and there is a variation in pressure and volume of a gas, so you can use the Boyle's law. Here what we have, first I am going to write the information given and required. We have initial pressure 300 kilopascal. In the first case the length of cylinder was 100 centimeter. So first you will make change centimeter to meter divided by 100 and the cross sectional area was given 0.12. So volume you can get by multiplying length and cross sectional area. So you get the initial volume 0.12 cubic meter. Now what happens? The piston moves. Because of that the length becomes 40. In this case you need to calculate the new pressure. What is the new volume Again, this time the length reduced to 40. But in centimeters, so you divide 40 with the 100 to convert in meter. The area of the piston is same 0.12. Multiply the numbers, then you get final volume. Now, move on to this side. You can use the equation of Boyle's law. P1 times V1 is equals to P2 times V2. P1 300 kilopascal, V1 0.12 cubic meter. P2 you need to calculate, and you calculated V2 0.048 cubic meter. Multiply the number, then you get 36 left hand side. And what we need, you need P2 actually, P2 as a subject, 36 over 0.048, divide the number, then you get 750 kilopascal. So that is the new pressure. The last part of this question, look at this. Explain in terms of behavior of molecules why the gas pressure has changed. You know well, when the piston moves and the length reduced to 40 centimeter, that causes a small volume or a small capacity. When the capacity is small or volume is small, due to this less availability of space, gas molecules hit the wall of cylinder frequently, or they make more collision in the given time. So that's why the pressure increases. So here you write gas molecules collide more often, or more number of collision with the walls of a container per unit time. That causes increase in pressure. This is question number 6. Figure 6.1 shows a scale diagram of a plane wave fronts approaching a gap in a barrier. Look at this diagram. These arrows indicate the direction of wave travel. This is the barrier, and this part is showing the gap of barrier. These horizontal lines are plane wavefronts. In part A, what we need, on figure 6.1, draw the pattern of wavefronts after the wave has passed through a gap. You know well, the gap between these two wavefront is equals to one wavelength. When this wavelength is equal to this size of gap, then diffraction of wave takes place. In diffraction, what happens? The wave is spread out, and here you need to draw what would happen with the wavefronts of the wave when through the gap. After through the gap, you draw the wavefront like this, semicircles, and these are the direction of wave through the gap. Now, be careful when you draw these semicircles in exam. The distance between the two semicircles should be same by an eye. Okay, so you will award 2 marks for this construction. Part B. The wave approaching the barrier has a wavelength 2.5 centimeter, that is lambda. Speed is 20 centimeter V. Calculate the frequency. You know well this wave equation, V is equals to F times lambda. You need frequency, so you can make frequency as a subject. V over lambda is equals to F. And you can write F is equals to V, and V is 20 centimeter per second divided by wavelength 2.5 centimeter. 20 over 2.5 gives you 8, and these units cancel out. We get only S minus 1, or that is equals to Hertz. So here you can write the frequency of the wave is 8 Hertz, or 8 waves per second. You will be awarded 2 marks for this answer. C. State what happens if anything to the frequency of the wave as it passes through the gap. Remember few things. What happens with the wave in case of diffraction? Speed and wavelength change, but frequency does not. So here you can write, of course, diffraction is there, but frequency does not change. So you can write here frequency remains same. Or you can write constant or unchanged. So you will be awarded 1 mark for this answer. Part B. Explain in terms of diffraction why a car radio may pick up low frequency radio signals but not pick up high radio signals when the car is traveling behind a hill. Look at this diagram. There is a hill and there is a car traveling this side. Remember one thing, this is the direction of radio wave, left to right. These vertical lines are called wavefront. The distance between two wavefront is equals to 1 wavelength. The condition for the diffraction is that this wavelength is comparable with the size of obstacle. If the size of obstacle in front of wave is comparable with the wavelength, then diffraction takes place. So when we use the low frequency signals have longer wavelength. So longer wavelength are comparable with the size of hill. That's why the wave diffract and get the signal. So here you write low frequency signals have long wavelength, so signal diffract more. On the other hand, high frequency signals have the short wavelength and we get the less diffraction. Thank you very much for watching this video. I suggest you follow the playlist of the channel. In that you can find all the lessons you need in your IGCSE physics. So keep watching Physics with Safdar for better results in exam. See you in the next lesson.